Yes, we have come across the vector equation of a straight line passing through the point A bar and parallel to vector B bar as R bar is equal to A bar plus SB bar. And also we come across about the vector equation of a straight line passing through the 2 points A bar and B bar is given by R bar is equal to 1 minus S into A bar plus SB bar. Now, how you can make use both the lines, both the vector equation you can make use in any one of the applications. Say for example, I am going to take example. What is that? Let the position vectors of the vertices of triangle ABC are A bar, B bar, C bar respectively, then equation of median from capital A to the side BC. How you can apply both R bar is equal to A bar plus SB bar or R bar is equal to 1 minus S into A bar plus SB bar. Now you take this as a what? Triangle. What is this triangle? This is A of A bar, this is B of B bar, this is C of C bar. Now this is the median which meets at D. Now I take the solution of this is in a triangle ABC, OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar, be the position vectors PVS of capital A, B, C respectively. Let D be the midpoint of the side BC. Then by definition the position vector of a midpoint OD bar is equal to OB bar plus OC bar by 2, which implies B bar plus C bar by 2. Now I want to find out, this is the median, AD bar is the median. So therefore, now I want to tell the definition of collinear vectors or parallel vectors. When any two vectors are said to be either collinear or parallel, one vector can be expressed as scalar multiple of another vector. So therefore, what I do is the equation of median AD bar is equation of line through the point A and parallel to AD bar. Sir, you are asking the median AD, you are saying parallel to AD. Means that the median may be along AD, may be parallel to AD. If it is like this, parallel, one vector can be expressed as scalar multiple of another vector. If it is like this, there also you can make it as what? Collinearity. So therefore, now I can write parallel to AD bar is given by R bar is equal to OA bar plus S into AD bar. I can write this one as R bar is equal to A bar S into the vector AD bar is not given. It's a OD minus OA. I can write R bar is equal to A bar plus S into B bar plus C bar by 2 minus A bar. You can also go by the vector equation of line joining these 2 points also you can go. R bar is equal to 1 minus S into A bar and S into A bar plus S into OD bar also you can write. So therefore, this is the application of both the vector equation of a straight line passing through the point A bar parallel to vector B bar I made use, or else you can go for what? The vector equation of a straight line passing through the 2 points A bar and B bar. That vector equation can also be used here. It all depends upon the options which are given in your paper. Followed? So therefore, this gives the equation of the median from A to the what side? BC. Again, in a triangle ABC, now A bar, B bar, C bar be the what? Position vectors. Then the equation of median from A to the side what? BC. So therefore, in a triangle ABC, OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar. Here is the O, OA, OB, OC, OD, right? D be the midpoint of the side BC, correct or not? Then, by using the position vector of a midpoint, that is the sum of the 2 position vectors by 2, which divides in the ratio of 1:1. OB bar plus OC bar by 2 is equal to B bar plus C bar by 2. So therefore, equation of a median AD bar is equation of a line is equation of line through the point A and parallel to what? AD bar is given by R bar is equal to OA bar plus S into AD bar. So therefore, I can write the vector equation of a straight line. So passing to the point A parallel to AD bar is A bar plus S into B bar plus C bar by 2 minus A bar. Right. Yes, now look here, students. Now the another application of the vector equation of a straight lines. First one is R bar is equal to A bar plus SB bar. The second one is R bar is equal to A bar, that is 1 minus S into A bar plus SB bar plus SB bar. Now what I do is, what is given, the application of this one is, P is a point on the line through the point A. I am going to select, this is A of A bar and P of R bar. AP bar is a one vector. So, A bar, and the line is parallel to the vector B bar. This is a vector B bar. Right. If PA is equal to lambda, this length is what? Lambda. Then the position vector of P is dash. Now what I do is, now P is a point on the line which is passing through the point A bar, and this line is parallel to what vector? B bar. What I do is, now scalar multiplication of a vector. If you multiply scalar with a vector, is once again a vector. Its magnitude has been increased or decreased, depends upon the value of what? Scalar. Say for example, if I go to this one is, this is A bar, I can write This is a what? Length lambda a bar. This I can lambda a bar, where maybe lambda is equal to 2. Now if I go like this, lambda, this is what? This is also lambda a bar, but lambda is equal to what? Minus 2. If I go like this is what? Lambda a bar, where lambda is equal to minus of. Minus of. So therefore, now these are all nothing but what? Scalar multiplication of vectors. So therefore, if you multiply any scalar with a vector, is once again a what? Vector quantity. Is once again a vector quantity. What I am doing is, the unit vector in the direction of unit vector along in the direction of b bar of length lambda is given by PA bar or AP bar is equal to lambda into what? B cap. Why? If you take a magnitude of length, its length becomes what? 1, and this is parallel to what? AP bar. Once again its length will be what? Lambda. As I told earlier classes, the vector of length lambda, which is directed along the interval bisector of a bar and b bar, is lambda into a cap plus b cap by modulus of a cap plus b cap. So therefore, in vectors, if you want a vector of any length, required length, that length you have to multiply always with the what? Unit vector. Unit vector. So therefore, I want a vector. This is along what? B cap. Of what length? Lambda. So therefore, maybe in the same direction, maybe in the what? Opposite direction. Opposite direction minus, same direction plus. So therefore, now I can write, this is OP minus OA is equal to lambda into B bar by modulus of B bar, which implies R bar minus A bar is equal to lambda into B bar by modulus of B bar. So therefore, R bar is equal to A bar plus lambda into B bar by modulus of B bar. This is nothing but a P is a point on the line passing through the point A, whose position vector is what? A bar. And the line is parallel. Which line? AP or PA is parallel to what? B bar. But the length of PA is what? Lambda. What I took? Just I took the unit vector in the direction of B bar. So therefore, AP bar is parallel to what? B bar. So therefore, I took lambda into what? B cap. What length? Lambda. So therefore, OP minus OA is equal to lambda into B bar by modulus of B bar. So therefore, R bar minus A bar is equal to lambda into B bar by modulus of B bar. So therefore, R bar is equal to A bar plus lambda into B bar by modulus of B bar. This gives the position vector of a point P. Okay. Right. Yes, students, up to now we discussed about elaborately regarding the vector equation of a straight line passing through the point A bar and parallel to vector what? B bar. Parallel to vector B bar. And also is what? R bar is equal to A bar plus SB bar. And also we come across about the vector equation of a straight line passing through how many points? 2 points. A bar and B bar is R bar is equal to 1 minus S into A bar plus SB bar. After knowing the what? Vector equation of straight lines, let us move to understand the types of the equation of planes in vector, that is vectors. The very first one is, now vector equation of plane. Vector equation of a plane. What is that? The vector equation of a plane passing through passing through a point, passing through the point A of A bar and parallel to the vectors B bar comma C bar. Yes, R bar is equal to A bar plus SB bar plus TC bar. R bar is equal to A bar plus SB bar plus TC bar. Now what I do is, when R bar is equal to A bar plus SB bar plus TC bar, now let us see where S, T are the scalars belongs to R. You take a plane. This plane is passing through the point A bar. Remember, whenever one point is given in the what? Either in vector equation of a straight line or vector equation of a plane, you have to consider the what? The unknown point, second point P as what? R bar. Why? To name it as a line or a plane. So therefore, now it's AP bar. By joining the 2 points, 2 position vectors, we can obtain one vector. So therefore, now coming this one is, this is nothing but B bar, this is nothing but a C bar. Means these 2 vectors are what? Parallel to the plane. What's a plane? My hand is a plane, right? My hand is a plane. Now these 2 are parallel to this plane. Your book is a plane, your whiteboard is a plane, correct? Varieties of planes. So therefore, now this is a plane passing through the point A bar and parallel to the vector B bar and C bar, parallel to vector B bar and C bar. Now let us see. I start. How this is can be interpreted. Let OA bar is equal to A bar and P be a point in the plane and OP bar is equal to R bar be the position vectors. Position vectors. Let B bar comma C bar be two vectors parallel to the plane, vectors which are parallel to the plane, parallel to the plane. So therefore, from figure, the vectors AP bar comma B bar are lying in the same plane. Which implies AP bar comma B bar comma C bar are coplanar. There exists scalars s comma t such that whenever any three vectors are said to be coplanar, one vector can be expressed as a linear combination of remaining vectors. What is that? One vector can be expressed as a linear combination of remaining vectors. Therefore, I can write AP bar, which comprises unknown OP. It must be free from the scalar multiple. I can write SB bar plus TC bar, where S comma T belongs to R. But AP bar is not given. Its position vectors are given. So therefore, what I do is, now AP bar is OP minus OA. OP minus OA. This is S into B bar plus T into C bar, which implies R bar minus A bar is equal to SB bar plus TC bar. Therefore, finally, R bar is equal to A bar plus SB bar plus TC bar, where S comma T belongs to R. Yes, students, today we arrived at the vector equation of a plane passing through one point and parallel to how many vectors? Two vectors, B bar and C bar, is given by R bar is equal to A bar plus S into B bar plus T into C bar plus T into C bar. So therefore, now here, therefore, let us see how I interpreted it. Let A of A bar, P of R bar be the what? Two points whose position vectors are what? A bar, B bar, C bar. This plane is parallel to what? B bar and C bar. Parallel to B bar and C bar. Now, so from the figure, the vectors, what are the vectors? The vectors AP bar, comma B bar, comma C bar are lying in the same plane. This is a plane which may contain, look at, this is the what? AP bar. This is AP bar. When this is AP bar, this is B bar, this is what? C bar. This plane may contain one vector, may contain 100 vectors. For all of them, these two vectors are what? Parallel. What's the definition of coplanarity? The vectors which are lying in a same plane are a parallel planes. With that, this is a plane containing AP bar. This is what? B bar. This is what? C bar. Means all are, even that they are parallel to a plane, it means that they are lying in a what? Same plane. It's a quite obvious. Therefore, when they are lying in a same plane, what they are? Coplanar. When any three vectors are said to be coplanar, one vector can be expressed as a linear combination of remaining vectors. AP bar is not given. Its position vectors are given. Therefore, OP minus OA is equal to SB bar plus TC bar. So therefore, R bar minus A bar is equal to SB bar plus TC bar. So therefore, R bar is equal to A bar plus SB bar plus TC bar, where S comma T belongs to R. This is the vector equation of a plane passing through one point A bar and parallel to vectors B bar and C bar. B bar and C bar. Yes, now we have discussed the vector equation of plane passing through the point A bar and parallel to vectors B bar and C bar. Let us discuss the same plane in Cartesian form. The theorem is the Cartesian the Cartesian equation of a plane passing through the point A of A bar and parallel to the vectors B bar and C bar is I can write box of x, that is determinant of x minus a1, y minus a2, z minus a3 is equal to 0. Now, it's a b1, it's a b2, it's a b3, c1, c2, c3. Right. What's a figure? Once again, the same approach. If I take this as A of A bar, P of R bar. When one point is given, you are supposed to take what? Second point. This is nothing but B bar. This is nothing but what? C bar. AP bar, B bar and C bar. Now what I do is, the proof of this one is, let OA bar is equal to A bar is equal to A1I plus A2J, A3K, and OP bar is equal to R bar is equal to Xi plus Yj, Zk. This can also be written as, this is nothing but XYZ. Now, be the position vectors of B bar is equal to B1I, B2J, B3K, C1I, C2J plus C3K. B2 vectors are parallel to the plane, parallel to the plane, parallel to the plane. From figure, AP bar, B bar, C bar are lying in the same plane, which implies are coplanar. Coplanar vectors are linearly dependent. I told the second method, determinant value is equal to what? 0. Why? So therefore, now I can coplanar, which implies determinant value is equal to 0. So therefore, I can write, that is coplanar, AP bar OP minus OA, B bar, what is OP minus OA? That is AP OP minus OA. This is OP minus OA, means x minus a1 into I plus y minus a2 into j plus z minus a3 into k. Right? Here you write x minus a1 Next, y minus a2. This is z minus a3. This is ap bar. So therefore, what is b bar? b1, it's about b2, it's about b3, or what c1, it's about c2 and c3. As I told, coplanar vectors are what? Linearly dependent. One is linear combination method, other one is what? Determinant method. For determinant method, actually, if you get into the multiple product of vectors, there is the necessary and sufficient condition for any three vectors to be coplanar is box of AP bar, B bar, C bar is equal to 0. Box of AP bar, B bar, C bar is equal to 0. That box is nothing but a what? Determinant. So therefore, since the vectors are in terms of ijk, determinant into box of ijk is equal to 1. So therefore, the condition for the theorem or a concept on this, the necessary and sufficient condition for any three vectors to be coplanar is box of AP bar, B bar, C bar is equal to 0. Box of AP bar, B bar, C bar is equal to 0. Followed? Right. Now I went for det is equal to 0. If you expand, you are going to get what? The equation of a plane in a Cartesian form. In a Cartesian form. That will be in terms of, this may be in terms of like this, AX, it may be BY, CZ plus D is equal, CZ plus D is equal to 0. This represents, after expansion, you get. So therefore, this is in terms of Cartesian form, and R bar is equal to, I told, the other one is R bar is equal to A bar plus SB bar plus TC bar. This represents the vector equation of a straight line. The vector equation of a straight line. Followed? Right. Now, let us give one example on this. He asks, example is, A of 1, 2, 3, B of, okay, or else be the point, and B bar is equal to 1, 3, 4, C bar is equal to 2, 4, 8. B2 vectors. Then first one, the vector equation of a line, the vector equation of a plane passing through the point A and parallel to B bar, C bar is dash. The second one is the perpendicular distance, or else the intercepts of the plane, or sum of the intercepts, as you please, the intercepts of the plane passing through the point A and parallel to vectors B bar, C bar or dash. Let us see. Now the solution of 1. The vector equation of a plane. The vector equation of plane through the point A of, it is a point 1, 2, 3 This is nothing but what? A bar or OA bar is nothing but A bar, and parallel to vectors B bar is equal to 1, 3, 4 and C bar is equal to 2, 4, 8 is R bar is equal to, just you substitute, that gives R bar is equal to I plus 2j plus 3k plus S into T into, this is very simple. I want to find out the Cartesian equation. The second one is the Cartesian equation of plane. Cartesian equation of plane is equal to 0. X minus 1, y minus 2, z minus 3. Next, parallel to B bar and C bar. 1, 3, 4, 2, 4, 8. 2, 4, 8. Now you expand. So I can write this one as x minus 1 into AD minus BC, this into this, 24 minus 16 minus y minus 2 into, yes, come on, 8 minus 8 plus z minus 3 into 1 into 4, 4 minus 6 is equal to 0. So therefore x minus 1 into 8 minus 0 minus 0. Yes, now I can write z minus 3 into minus 2. Just you expand 8x minus 8 minus 2z plus 6 is equal to 0. So therefore 8x minus 2z is equal to, therefore x by, is now x by 1 by 4 plus z by minus 1 is equal to 1. So therefore which implies intercepts are, or else which implies intercept are 1 by 4 comma 0 comma minus 1. This represents the Cartesian equation of a plane passing through a point A bar and parallel to the two vectors B bar and C bar. And this gives the vector equation of a plane passing through a point A bar and parallel to the vectors B bar and C bar. B bar and C bar. Right, next, let us move to understand the vector equation of a plane. Another vector equation of a plane. What is that? The vector equation of a plane passing through 2 points and parallel to one vector. Parallel to one vector. The vector equation of a plane passing through the points A bar comma B bar and parallel to vector C bar is R bar is equal to 1 minus S into A bar plus SB bar plus TC bar, where S comma T belongs to R. So therefore, let us see how this comes. If I take this as this is a plane passing through 2 points. When the 2 points are given, you have to select the third point. That third point is nothing but a what? P of R bar. To name it as a plane, we want a R bar. So therefore, this plane is parallel to what vector? C bar. Now what I do is, let OA bar is equal to A bar, OB bar is equal to B bar, is equal to R bar, be the position vectors, the points A, B and P respectively. C bar be the vector, C bar be the vector parallel to the plane. To the plane. From figure, the vectors AP bar, AB bar, C bar are lying in the same plane. You can very well observe. Now they have given 2 points and I consider the third point, that is P of R bar. Then why you have taken AP bar and AB bar? Why can't you take, sir, AP bar and BC bar, BA bar or what? PB bar, BP bar. When, look, I told OA bar is equal to A bar, OB bar is equal to what? B bar. AOB is the plane generated by what? A bar and B bar. So therefore, when you are in a plane, when you are given with the what points, when you want to construct a mass of vectors, they must be coinitial vectors. They must be coinitial vectors. Therefore, now either AB bar, AP bar or BA bar, BP bar, not with P. P of we considered. So therefore, they must be coinitial vectors. Either AB bar, AP bar or, tell me, BA bar or BP bar. Yes, therefore, now what in the same plane. So therefore, now I can write, yes, now C bar, same plane. So then plane which implies AP bar, AB bar, C bar, what they are? Coplanar. There exists scalars S, T such that one vector can be expressed as linear S into AB bar, T into C bar. So therefore, AP bar is not given, its position vectors are given OP minus OA, S into OB minus OA, T into C bar. This is R bar minus A bar, S into B bar, C bar. Now R bar is equal to 1 minus S into A bar plus TB bar, SB bar plus TC bar, where S comma T belongs to R. Remember, we have arrived at the linear combination R bar is equal to 1 minus S into A bar plus SB bar plus TC bar. So therefore, once again, let OA bar is equal to A bar, OB bar is equal to B bar, OP bar is equal to B bar be the position vectors of 3 points, P be any point in the plane. So therefore, now position vectors, C bar with the vector parallel to the what? Plane. When it is parallel to the plane, from figure, the vectors AP bar, AB bar, comma C bar are lying in the what? Same plane, which implies AP bar, AB bar, C bar are coplanar. What they are? Coplanar. So therefore, there exists a scalar such that S comma T, AP bar is equal to 1 vector can be expressed as linear combination of remaining vectors. When any 3 vectors are said to be coplanar, 1 vector can be expressed as linear combination of remaining vectors. So therefore, OP minus OA, AP bar is not given, its position vectors are given. AB bar is not given, its position vectors are given. OB minus OA, C bar is a vector. Now its position vector is A bar, R bar, B bar, A bar. Therefore, R bar minus A bar, S into B bar minus A bar plus TC bar. Therefore, finally we arrived at R bar is equal to what? 1 minus S into A bar plus SB bar plus TC bar. This represents the vector equation of a plane passing through how many points? 2 points. That is 2 points and parallel to what? 1 vector. Other one I told in the starting, R bar is equal to A bar plus SB bar plus TC bar. That represents the vector equation of a plane passing through 1 point parallel to 2 vectors. Here passing through 2 points and parallel to 1 vector, C bar is given by this. This is the vector equation of a plane. In the same fashion, we have to prove that the Cartesian equation of a plane passing through the what? 2 points, A bar is equal to A1, A2, A3, and B bar is equal to B1, B2, B3, and parallel to the vector C bar is equal to C1, C2, C3. We'll get it. How? As I told, the necessary and sufficient condition we come across in the next. The necessary and sufficient condition for any 3 vectors to be coplanar means box of them, those vectors, is equal to 0. By using that concept, we can find out the Cartesian equation of a plane passing through 2 points and parallel to 1 vector.